Very carefully. Everybody listen. Now, understand there are many ways to do this one, but keep in mind, those of you that did it the harder way, it was a little bit harder, obviously. So watch how I did it, and then you can see like, oh yeah, she gave me that suggestion for a reason. A lot of you still got it right, which is great. If you got the right answer, great, but watch just in case for future you want to use this way. Okay, the first thing we really should have done, you guys, just to make our lives easier in the end, is simplify from the get-go. A lot of you did not do that. You just split it up and rationalized, which was fine, but then did you see how you had to do all that pulling out in the end? Okay, so what should we simplify first? 2 and 4 becomes 1 over 2. X and x squared becomes 1 over, and then y and y cubed becomes y squared on bottom, doesn't it? Now look, z and z divides out right here, right now. Now, once again, a lot of you still got the right answer. 1 was left on top. So now I would split it up. We have the cube root of 1 divided by the cube root of 2xy squared. And now we would rationalize the denominator. So remember, to get a cube root to cancel out, you need everything to be cubed. So we're going to multiply by the cube root of how many more 2's do we need? 2 more to make it 2 cubed. X, we need 2 more x's to make it x cubed. Y squared, we only need 1 more y. If you do that to the bottom, you do that same thing to the top. 2 times x, x, y. 1 times all that stuff is all that stuff. So we have the cube root of 4, x squared y on top, and on bottom, technically, we have the cube root of 8, don't we? 2 times 2 times 2, everybody. And then we have an x times x, which is x cubed. And then now we have a y squared times y, which is y cubed. What's the cube root of 8? Cube root of x cubed. Cube root of y cubed. So this is our final answer. So as you can see, many of you reached that answer. It just took a little bit more work, which is fine. But just notice, simplifying first kind of makes our lives a little easier. All right, very good. Can anyone tell me, how do I rationalize something like this with 2 terms on bottom? We can't add them because they're not like radicals. Yes, you're right, and you're right. We multiply by it's called a conjugate, people. If you have 2 terms and you have a radical and you need to fix the radical, the only way to fix it is to multiply by the conjugate. Remember, conjugate means exact same terms, just a change of sign in between. If you do that to the bottom, you've got to do that exact same thing to the top. Now understand, we do not need to rationalize the numerator. The numerator can have radicals, so that's why we picked to rationalize the denominator. The next thing to know, if you have 2 terms, you need to put parentheses, otherwise you're going to probably mess up in your multiplication. What I want you to do is finish this one off. Multiply out the top, multiply out the bottom. If you fill out a radical on bottom, either you rationalize by the wrong thing, or you've made an error somewhere. Because the whole goal of this was to get rid of a radical. Ready, go. Okay, check your numerator. Did you get this? Then last thing you do is check to see if any of your radicals simplify. That one doesn't. That one does. It becomes a 2. So we have root 10 minus 2 minus root 15, which also doesn't break down, plus root 6, which doesn't break down. We can't combine any of those radicals. They're not the same. How many got the top right? Nice. Now in our denominator, we got this, which our middle terms cancel out. Root 25 is 5 minus 2, which is 3. So our denominator was 3. So we had all that stuff divided by 3. Is that our final answer? Yeah. We fixed the problem. There is no radical, and we can't divide what's under a radical with what's not, so we're good to go. We also couldn't divide across a subtraction sign or anything. I rationalize this one? The problem is radical on bottom. How should I rationalize it? Yeah, multiply by the conjugate. We have two terms, guys. The rules don't change. So what would the conjugate be? Okay, good. Now, once again, you should be saying to yourself, if there is two terms ever and I'm doing multiplication, I need parentheses. Finish that one off for me. So on top, you should be looking at this. 3 plus 3 root 2s minus root 3s minus root 6s. Sweet. Then nothing can combine. On bottom, we're looking at this. And my middle terms cancel out. So then now we have 1 minus 2, which is? So we have all that stuff divided by negative 1. Now on a multiple choice test, you would never see that as your final answer. Yes. Yeah, let's do simplify. So as long as we divide each term by negative 1, we can do it. They wouldn't keep their answer negative on bottom. They would always pull that negative to the top. And then divided by 1 is just, 1 itself, right? Sorry. 3 divided by negative 1. 3 root 2 divided by negative 1. Negative 3 root 2. Negative root 3 divided by negative 1. Positive root 3. Negative divided by a negative is a positive. And anything divided by 1 is just itself. So that would be our final answer there. That is such a good problem to remember for the test. Okay, very similar. Okay, here we go. Let's get on to today's lesson. So today's lesson is one of my favorites because it's very straightforward. It's just algebra, which is super nice. So, okay, understand, in this unit so far, all we have done is simplify. We have not solved. Today we're going to be solving. Now here's the difference, because I hear a lot of you use the vocabulary wrong. Because you'll say to me, should I solve this, Ms. Christensen? And then I say, wait, do you mean simplify? Because solving means go all the way and solve for x. X equals 10, for example. So all we've done is add, subtract, multiply, and divide, and then simplify, right? We have not solved for any variables. Now, solving is when you have an equal sign. Only if you have an equal sign will you solve for the variable all the way. So then, today that's what we're going to be dealing with, is actually solving for a variable. Here are the step-by-step instructions. Take a picture or write them down very quickly. This is the whole lesson, then we just practice right here. So first, the first thing we do when solving a radical equation is get the radical all by itself. That's what I mean by isolate the radical. So nothing should be multiplied or divided to your radical, and nothing should be added or subtracted to your radical. And then, so once the radical is all by itself, everybody, then we can undo the radical, but only if the radical is all by itself. So once we have the radical all by itself, we undo the radical using correct inverses. Now guys, what undoes addition, subtraction? What undoes multiplication, division, right? So what undoes a square root? A square. What undoes a cube root. What undoes something to the 5th power? A 5th root. What undoes a 6th root? A 6th power. Then third, once you've undone the radical using the correct inverse, you will then solve for that variable or solve for x. Now we might be solving something linear and we might be solving something quadratic. Now if we're solving something linear, it's just solve for x. If it's quadratic, we have to get it set equal to 0, put it in standard form, and then solve by factoring. Did everybody hear that? Yep. Then fourth, because we're going to be changing both sides of the equation, we're doing all this changing of the problem, even though it's correct, we can introduce extraneous solutions. So we just have to check our solutions. Now remember, an extraneous solution is a solution that is derived of the original equation, of the new equation, but is not a true solution of the original. So we'll just check our answers. But luckily, the checking on this is way easier than the last unit. Remember the last unit? Yikes. Here we go. Let's begin. Number 1. So the first thing is to, every single time, this is always the same steps, get the radical completely by itself. So we would use algebra. So we subtract 2. So we would have 5 square roots of x equals 10. Now you cannot, I would not undo the radical right here. First, get the radical alone. So we need to divide by 5 first. Did everybody hear that? Yeah. Very important. So we have root x equals 10 divided by 5 is 2. Solve for x. So now we can undo our radical. What undoes a square root? A square. So now look, root cancels out with power. So x equals, I would use parentheses. 2 squared is 4. And there's our solution. So it's just algebra. Very straightforward algebra. Now watch, let's check it. So it's nice as you can hand in your test knowing you've already got these problems right. So look, plug it into the original. 5 squared is a 4 plus 2, does that equal 12? That's 5 times 2, because it's in square root of 4, 2. Plus 12, does that truly equal 12? Sorry, plus 2, does that equal 12? 10 plus 2, does that equal 12? Yes, so we are good to go. Let's do another one. First step on number 4 is get the radical alone. Isn't my radical good to go? Yep. All this stuff is trapped underneath my radical. So I've got to undo the radical before I do anything with all this stuff. So wouldn't we square both sides? So root cancels out with power. We have 2x minus 5 equals 7 squared is 49. Solve for x. So we'd add 5. So we have 2x equals 54. Divide by 2, divide by 2, x equals 27. Let's check it. So we go off to the side. We type into our calculator the square root of 2 times 27. Minus 5 was under that radical. Does that equal 7? Type that into your calculator, hit enter. Type it into your calculator, hit enter. Yep, 7 equals 7. We are good to go. So if you got it, let's say you didn't get a true statement, either one of two things happened. It's extraneous or you've done it wrong. Both are signals. I better try it one more time. If you get the same answer, it's probably just extraneous. Okay, look at number 6. What should I do first? Yep, we've got to isolate the radical. The rules never change. Subtract 5. Square root of 5 minus 2x equals 7. What's my next step? You mean square? Perfect. Square both sides. Good job. And then we have 5 minus 2x equals 49. Now, a lot of people will get their eyeballs backwards and they'll say, oh, that's negative 5. Well, we look at this from left to right. That's positive 5. So shouldn't we subtract 5? So we have negative 2x equals positive 44. That's a 44, sorry. All right, next step. Okay, very good. So x equals negative 22. Let's go check it. So you type in your calculator the square root of 5 minus 2 times negative 22. Plus 5 out here, does that equal 12? Everybody type it in. Yes. Okay, we're good to go. You guys getting the picture here? Okay, sweet. Easy peasy pudding pie. Ready? Do 11 by yourself. I'm going to just do it from my video. Don't look up here until you're checking your final answer. Yep.
Thank you.
Okay, did you get x equals 5?
Yes.
And then you checked it, and you got 0 equals 0, didn't you? Okay, cool. Do 1 through 12. Finish up 1 through 12. So, a couple of things to look at. Look at 13 with me. So, we know that if we have a rational exponent, it is literally equal to a radical. So, we could write rational exponents as a radical, technically, couldn't we? If we have a rational exponent, couldn't we rewrite it as a radical? Roots go on bottom, powers go on top. So, look at 13. Now, here's what you're going to have to be careful of. Is all that stuff under the radical or is some of it not? So everybody look, because there's parentheses, isn't all that stuff under a cube root? And all that stuff is raised to the first power. So let's rewrite it. We have the cube root of x minus 2 to the first power. Same thing. That equals 5. And now do you see how it's no different than what we just did? So now we would literally solve for x just like we did before. Isolate the radical. It's isolated under the radical. What should I do? Cube it. If it's a cube root, we would cube both sides. So I'm correcting like how you're saying it. Now we have x minus 2 to the first power equals 5 to the third. We should use parentheses, guys. 5, because in the future you're going to have negatives. Does that make sense? So 5 to the third power is 125. It's okay though. And then keep in mind, because this is to the first power, we could just write x minus 2 equals 125. Therefore, x equals 127. Yeah, we do need to check it. So watch, this is the checking part will be kind of nice. You can just type in 127 minus 2 in your calculator, raised to the 1/3 power, hit enter. Does 5 equal 5? Yes. Okay, cool. Now, guess what? Watch. There's advanced thinkers out there. We could not go as far as rewriting it. Instead, we could have thought of this algebraically the same way. So watch. This is how we do it in honors instead. Instead of taking the time to rewrite it as a radical, we just say, okay, this is my radical technically, right? It's all by itself. So I'm going to raise both sides to the 3rd power. Same thing, right, that we did? But now look, raise a power to a power and you multiply. A 3rd times 3 is 1. So that's where we're getting our x minus 2. Does everybody see? And then we get, same thing, 125. So same thing, it's just how do you want to think about it? Let's do another one. 15. This one gets people. Here is why. People will treat this like this. There is a huge difference between 2x all to the 3/4 power equals 16. Remember how on day 1 I made such a big deal about parentheses? It's for this reason. If you rewrite this as this, you're going to be wrong. So is 2 raised to the 3/4 power? No. So this is 2 times the 4th root of x cubed. 2 is not under the radical. If it was written like this, we would have wrote 4th root of 2x all cubed. Do you see the difference? So we're really looking at this equals 16. So our first step is to isolate the radical. So what should I do? So we have the 4th root of x cubed equals 8. Now undo the radical. So what would I do first? What would I do? Raise both sides to the? So x cubed equals 4096. And then we'll cube root both sides of the equation. Now root cancels out with power, so x is equal to, now here's one thing to note. With cube roots, don't they only have one answer? If we were taking an even root, don't they get plus and minuses, technically, right? Well, it's an odd root, so we don't have a plus or minus. So the cube root of 4096 is, thank you. And then you would go back up and check it. So you would do in your calculator 2 parentheses, 2 is not in parentheses, 2 times parentheses 16 raised to the 3/4 power. Hit enter. If that's 16, we're good to go. It works? Yes. Yes, so everybody, look back. Let's look at it the advanced way. Everybody, because I know there's some advanced thinkers in here that would rather just jump right to the case, like cut. So look, we would first have to divide by 2. So then that's x to the 3/4 power equals 8, correct? What he's saying is, can't I just take both sides to the 4/3 power to make that a 1? 4/3, right? Everybody see? 12 over 12 is 1. Do you see how that took care of it? So we have x to the 1 equals 8 to the 4/3 power, and you hit enter and you get 16. So here's why I don't usually teach that in secondary math 3 regular, because it's really easy to miss problems like this one. Not this one, but the next one. So let's do this one. Ready, go. You guys do it. What should you do first? Add 5, right? X to the 1/2 power equals 5. Now, technically, once again, most of you should probably just take the time and quickly rewrite the square root of x equals 5. We're looking at this. So now to undo the radical, we would then square both sides. Root cancels out with power, x equals 25. So the only reason, once again, I don't usually teach that one way is for this problem in particular. So this is what I call a red flag problem, and you'll see why in just a second. So first step is isolate the radical. So what should I do first? Add 4. So we have x minus 2, all raised to the 2/3 power equals 9. This is why I really highly recommend rewriting it as a radical instead of thinking about it the advanced way so that you're less likely to miss what I'm about to show you. Originally, don't we have the cube root of x minus 2 squared equals 9. So now we need to undo the radical. So we would first cube both sides, wouldn't we? So then we have root cancels out power. We have x minus 2 squared equals 729. Yeah, I teach this all the live long day, that's why. Is everybody with me? What's my next step? Square root. Now guess what? In the process of solving, this is the first time that we have had to take an even root when solving, right? We've squared both sides. We have not taken a square root yet. So now think about it. Root cancels out with power. So we have x minus 2. Isn't there technically, remember the instructions that I said at the beginning? If I say find all the real square roots, you need plus and minuses, right? Remember, so we have to treat solving similar. So we're going to have to put a plus and minus. The square root of 729 is plus and minus 27. That is the statistically missed problem on the test. Don't be the statistic. Don't miss it because you forgot to put plus and minus. Yes. No, with this we're solving all the way for x, right? So we're going to get x equals an answer, so there's no unknowns. Okay, so we got to solve now. We have two separate answers. X minus 2 equals 27. And we also have x minus 2 equals negative 27. But we still have, we're not done. We've still got to keep going. So we'd use algebra. We'd add 2. X equals 29. We would add 2. A lot of people will just jump to the conclusion, oh, negative 29. Not true. Negative 27 plus 2 is negative 25. So in this one, do you see how my answers are not necessarily opposites? Okay. Now we got to go check them. Everybody, I want you to take your calculator. We have positive 29 and negative 25. Check them. Type into your calculator. 29 minus 2 to the 2/3 power minus 4. Does that equal 5? Negative 25 minus 2 to the 2/3 power. Does that minus 4? Does that equal 5? Check them. Okay, you said this one worked. What about this one? Perfect. So neither of those were extraneous. So we get to keep x equals 29 and x equals negative 25. So guys, here's a couple things that people confuse now after they see this. Is they, once they see, oh, so when we have a square root, we have to put a plus or minus. But that's only in the process of solving. So if I have this, for example, if we have 2x to the 3/2 power minus 5 equals 10, you see how people will say, oh, we have a square root. It's only when solving, though. So this is the square root of x cubed minus 5 equals 10. So when we're solving, we would add 5. We have the square root. So 2 times the square root of x cubed equals 15. Am I right? Divided by 2. It didn't come out pretty, but I'm just making this up on the fly. So then what would we do next? We'd square both sides. Did we take a square root? No. So do you see how we don't need a plus or minus anywhere yet? We didn't take a square root when solving. So then we have x cubed equals that squared over that squared. So 225 over 4, and then we would cube root. Like I said, I made up this problem, so it's not coming out pretty, but that can, you guys get what I'm saying now. Okay, sweet. Do this section, 13 through 27. Be wary of parentheses. Are we looking at this or are we looking at this? Very different. You don't want to be the statistic, you guys, because that's the, I'm not going to get an A on the test statistic. So we have on 24, 3x to the 4/3 power plus 5 equals 53. So we would first subtract 5, wouldn't we? 3x to the 4/3 equals negative, not negative, positive 48. Then you would divide both sides by 3, wouldn't you? Since 3 is not in parentheses. So we have x to the 4/3 equals, yep, 16. Now from there, everybody watch. What we originally have right here, right now, before we solve it, right now we have the cube root of x to the 4th power equals 16. Am I right? So we would cube both sides. Root cancels out power. X to the 4th equals. Now, what's my next step? Yep, 4th root both sides. Did we just take an even root when solving? Yep, we need plus and minus. Now, in that one problem a second ago, we still had to keep going and solve for x, but x is alone here. So plus and minus 8 would be the answer. Please don't miss that for the test, guys. It always is a bummer when you miss that. Okay, let's go to the story problems. You guys, your ACT is not going to just say solve. So they're going to give you a problem that is just as easy as solving. You just have to think a little bit. So just because there's words there does not mean you should just not do it or not say I don't know how, because that is completely incorrect. So it says the formula P is equal to 4 root A relates the perimeter P in units of square units to its area. Now everybody, what happens is a lot of you get stop right there and say I'm confused already. So pick it apart. What did it tell you? P is what? Perimeter. What else did it tell you? A is the area. Okay, it says, what is the area? So are we going to be looking for A? If the square window is shown below. So it gives you, even though you can't see it, P is 24. So shouldn't we plug that in for P? That's like what you're going to see on an ACT. You have 24 is equal to 4 times the square root of A. Now, is this any harder than any problem we've done? In fact, it's easier, really. So make sure that just because there's words there, you don't say, I can't do it. What should I do first? Okay, 6 equals the square root of A. Last step. Square both sides. 6 squared is 36 equals A. How about we solve for A? That's what it asked us to find was A, area. Good point. So we should probably put our units of measurements. Good point. So he's saying that we'd probably put square feet because area of length times width, a foot times a foot would be technically square feet. Yes. Good catch. Okay, let's go to the, we were in the kiddie pool before. Now let's get to the deep end. Here we go. Let's go over to the back. Here we go, everybody. Now we have to start thinking more advancedly. So the rules don't change. Isolate the radical, undo the radical, solve for x. You might have linear, you might have quadratic. So is my radical isolated? No. Yeah, it's by itself. Okay, undo the radical. So we square both sides. Look, 2 terms, you need parentheses. You can't just square a piece of a side. It's got to be the entire side or not squaring it at all. So root cancels out with power. So on the left we have x plus 1, which is nice. But over here, it would be breaking the most forbidden rule of all forbidden rules to just square that, wouldn't it? So what we have is this. Now understand, in the other problems, what we did next was square root. But look what happens. If you square root both sides, aren't I right back to the beginning? So that is not how we can solve this one. Well, how do we solve it? Well, it's a quadratic. We can't square root it. We're going to end up right back where we started. So we're going to have to solve the quadratic. How do we solve quadratics? Get them in standard form and get them equal to 0. So we have x plus 1 equals, this needs to be in standard form. So we have x minus 1 times x minus 1. We need to put that in standard form. So we have x plus 1 equals, let's multiply this out, x X squared minus x minus x. Can I write minus 2x without bothering anybody? Negative 1 times negative 1 plus 1. You cannot solve the quadratic unless it's equal to 0. So I need to make this side equal to 0. So subtract x. And I'm going to subtract 1. All in the same step, so I don't have to do it in 2 separate steps. Subtract x, subtract 1. So now look, on this side we have 0, which is what we want. 0 is equal to x squared minus 3x, and that's gone. Now we have a quadratic that's in standard form. It's set equal to 0. We are all set up to solve it. We solve by a couple methods, factoring or quadratic formula. All of ours will factor. You should not be using quadratic formula. So let's factor the quadratic. Why do we factor? So that we can then solve. So what should I factor out right here, right now? Pull out an x, left is x minus 3. Now, a lot of you say, I've solved. No, this and this are literally equal in form. So why do we factor it? So that we can then set each of those equal to 0 and solve for x. So we get x equals 0, don't we? Add 3 and x equals 3. Now that was a lot of manipulation. Once we get to the more advanced problems, there's a lot more chance for extraneous solutions. So you're going to see extraneous solution. Here's our first example. So now we would go off to the side and say, okay, I need to check my solution. So watch. Make yourself a little section, x equals 0, and make yourself a little section, x equals 3. Let's check 0. Now we're plugging in 0 for x. So we have the square root of 0 plus 1. Does that equal 0 minus 1? Now look, we're not solving. There's no variable here. We are just simplifying. Did everybody hear that? So we would have the square root of 1 equals negative 1. When simplifying, we don't put plus or minuses. When solving, we do. Or if in instructions I say find all of the real square roots. Did everybody hear that? So right now we're just simplified. What's the square root of 1? 1. No. When simplifying, you don't put plus or minus. You go with the primary root. So everybody, 1 equals negative 1? No. So that's extraneous. Cross out. It's not really a solution. Let's check 3. So we have the square root of 3 plus 1. Does that equal 3 minus 1? The square root of 4 equals 2. 2 equals 2. Am I right? Yup. So only keep that solution. So on a test, this is the kind of work you'd show. Then I knew you knew 0 was extraneous. Does that make sense, everybody? A little bit more involved of a problem. Okay, let's do number 31, but I'm going to let you do it by yourself. How should I rewrite this? The square root of x plus 7 to the first equals x minus 5. What's my next step? Square both sides, undo the radical. So we have x plus 7 to the first power, which is just x plus 7. That equals, can I square that, square that? Nope. So we would rewrite this as x minus 5 times x minus 5. So it's a quadratic again. We've got to get this set equal to 0 and solve. So you guys finish that one off. Ready, go. Did you get the answer? Okay, good. Check them. Plugging in 9. So we have 9 plus 7 to the 1/2 power. Does that equal 9 minus 5? So type that into your calculator, hit enter. So 4 equals 4. So we get to keep x equals 9. Let's check 2. 2 plus 7 to the 1/2 power equals 2 minus 5. Type that in. 3 equals equals -3. Do you see how we're getting that? Not true. Not true. Therefore, 2 is extraneous. Awesome. Doing good out there. So when checking, you literally just plug it in and directly simplify. Like there's no plus or minuses or anything. Does that kind of help? Okay. Go to 34. What's my first step? Steps never change. Isolate the radical. So what should I do? You gotta do what? Yeah, she's right. We've got to subtract 6. Guys, the first rule is get the radical alone. Root x equals x minus 6. What's my next step? Yep, square both sides. Square that, square that. Now look, root cancels out with power. We have x equals x minus 6 squared. Now remember, you could check, can I square root that? Well, don't I end right back up to the step above it? Then you're going to say, nah. Yes, good point. We've got to multiply it all out. So go for it. You guys finish off this one. We've got to set this quadratic equal to 0, put it in standard form, and solve after that. Continue.
What is though? Like, I'd be like both.
Yes, you would. You would not be in this class. You'd be teaching college.
I'd be teaching college.
Yep. Depends on the college.
So what's the most Harvard?
They make a lot of money. I'm going to punch you in the face if you don't do math right now. Hey.
That's recorded.
Ooh.
That is recorded.
It is. I knew. I knew it was going to be recorded. I just didn't care. I'll just edit it. Just kidding.
Are you being serious? That long?
Well, I'm trying to figure out what the heck. I don't remember that one being extraneous. Wait, why am I getting 9? What am I missing here? Oh, I did x minus 6, but the original is just 9, right? That's why I was like, what? Okay. That one works. Good point. I don't know why I keep doing that 4 minus 6 thing. That's bugging. Extraneous. Just like that. Yeah. Awesome. Okay, let's look at, you guys do 39. No harder than anything we've done. Ready, go. Don't look up here. That's cheating. Hey, check your answer. But guys, really, plugging it in all by yourself is totally different than hearing somebody else say it works. Because a second ago you saw me make an error. I sat there and was like, what's going on? And it's because I had wrote an extra minus 6. Did you get this one? Yes. Okay, let's do another one. Nope, never mind. Do this section, 29 to 38 and 40. Look at 42. The rules always apply. First, isolate the radical. That means even though there's two radicals, you still want one on one side of the equation and the other radical on the other side. You don't want to keep both radicals on the same side. So let's add that over. So now look at what we have. On the left, we have the square root of 7x minus 6 equals the square root of 5x plus 2. Now what you'll do is undo the radicals, correct? So we'd square both sides. So now look, root cancels out with power. We have 7x minus 6. Over here, nice, root cancels out power. Equals 5x plus 2. And then aren't we looking at the easiest problem so far, basically? Yep. Subtract 5x. 2x minus 6 equals 2. Add 6. 2x equals 8. X equals 4. You check it, it works. If you have two radicals, you need to move one radical to the other side and then undo the radical appropriately. Okay, these are the ones I want you to do. So circle these ones. So you have to do 1 through 40. And then you need to do these on top of it. 41, 43, 47, 50, 46, and 44. Now you are going to run into some things you have not seen before. Try to think a little bit and then ask me. Does everybody see what we're looking at here? This is problem number 44. Hey, look, we have a square root and a fourth root. What you're going to want to do is take care of the bigger root. So we're going to raise both sides to the what? Fourth. So then look, 4 times the half. 2. Does everybody see? Raise a power to a power and you multiply. 4 times the half is 2, everybody. And then over here, doesn't that root cancel out power? Now look at the problem. It's a quadratic. That multiply it out and finish it off.